Heating effect of electric current. Actually, when current is passing through a resistance, it becomes hot, very hot, and emits heat. When remember, when current will pass, so resistor will resist the flow of charge or flow of current. During this process, what happen? They becomes very hot and they emitting heat. So that is called heating effect of light. Okay. In this process, actually, what we can say that electrical energy is converting in the form of heat energy. So what is heating effect of electric current? See here, when an electric current passed through a high resistance wire like nichrome wire, tungsten wire, the resistance wire becomes very hot and produces heat. This is called heating effect of current. So initially, Jules have created one formula, obtained one relation between heating energy and current. So this we are going to prove. Expression of Joule's law of heating. The heating effect of current is obtained by transformation of electrical energy into heat energy. We have taken a resistance R, current I is flowing for time interval T. A resistance wire offers resistance to flow of current. So work must be done by the source to keep current continuously through resistance wire. See, one thing we have to know, actually, when we switch on any uh, current or resistance or any circuit, if we'll switch on, current will flow. The resistance offers the resistance of wire offers resistance for flow of charge. So due to flow of charge, there is what work done per unit charge. We know that is they are developing potential difference. So here, if we'll see the potential difference, if we make the potential difference continuous, तो external source have to do some work done. जब करंट का फ्लो होगा तो वहां पर क्या होगा, जो रेजिस्टिव वायर्स होंगे, जो रेजिस्टेंस वायर का होगा, वो क्या करता है, अपोज करता है. किसका अपोज करता है? फ्लो ऑफ चार्ज का. और जिसके कारण वहां पर क्या डेवलप होता है बेटा? पोटेंशियल डिफरेंस. बिकॉज वर्क डन पर यूनिट चार्ज इज वी नो एज पोटेंशियल डिफरेंस. तो पोटेंशियल डिफरेंस को मेंटेन करने के लिए what happened, the external source whatever we have applied cell or we have applied a generator. So always what happened, generator or external whatever source is there, they have to do some electric work done. वो जो electric work done करते हैं, that will convert in the form of heating effect. तो यहाँ पर हम heating effect find out करने जा रहे हैं. Current I flows through a resistance R for time t and maintain a potential difference V between the terminal of resistance. टर्मिनल ऑफ रेजिस्टेंस में V को मेंटेन करने के लिए, और यू कैन से द फ्लो ऑफ करंट I, कॉन्टिन्यूअस फ्लो ऑफ करंट के लिए द एक्सटर्नल सोर्स हैव टू डू सम वर्क डन. ठीक है, तो दिस वर्क डन वी हैव टू फाइंड. तो सी हियर, if current I flows through a resistance for time t, so what will be the flow of charge? We know current is equal to what? Current I is equal to what? Charge upon t. So charge is equal to what? Charge q is equal to it. So this charge q flow, charge q flows through resistance wire and maintain a potential difference V. To maintain potential difference, what is the work done? Work done by external source what we know, V is equal to what, W upon Q, हमें मालूम है पोटेंशियल डिफरेंस इज इक्वल टू क्या होता है, वर्क डन पर यूनिट चार्ज. तो वर्क डन इज इक्वल टू व्हाट, वर्क डन इज इक्वल टू W इज इक्वल टू व्हाट, Q into V. रिमेंबर V इज इक्वल टू व्हाट, हमें क्या मालूम है बेटा, V इज इक्वल टू व्हाट, W upon Q. तो टू मेंटेन पोटेंशियल डिफरेंस V, work done is equal to what, Q into V, and Q I have find it here IT. So W is equal to ITV. So this work done VIT is done by the external source. If we'll assume that there is no loss of energy, other form of energy, if there is no loss of energy other than heat energy के अलावा वहां पर कोई एनर्जी, अदर टाइप ऑफ एनर्जी लॉस इज नॉट देयर. तो हीट एनर्जी इज इक्वल टू व्हाट, हीट एनर्जी प्रोड्यूस्ड इन रेजिस्टेंस इज इक्वल टू वर्क डन बाय एक्सटर्नल सोर्स. So this work done is equal to what, I have find it here VIT. So this work done is equal to, or heat energy is equal to what, heat energy H is equal to VIT. See here by Ohm's law, if current I is there, resistance R, तो potential difference V is equal to IR. By Ohm's law V is equal to what, IR. If we'll put here, so H is equal to IR into I into T. This will becomes I square RT. So H is equal to I square RT. So this formula VIT or I square RT is the expression of क्या, Joule's law of heating. One other form we can use here. If we'll see, V is equal to IR. So I is equal to what, V upon R. If you are putting here I is equal to V upon R into T, so this also becomes V square T upon R. So this three formula you can write, all these three for the heat energy. H is equal to, so we are writing here H is equal to VIT, or we can write I square RT, or we can write V square T upon R. So this all combined formula we can write heating energy when resistance is R, current I is flowing for time T. The formula is I square RT, VIT in terms of V, or V square T upon R. See here, H is equal to I square RT. By this formula, what we can see, heat energy directly proportional to square of current, directly proportional to what, resistance of wire, and directly proportional to us time taken for which current is flowing. So this combined we can say this is Joule's law of heating. So Joule's law of heating formula we can see here, H is equal to I square R. By Joule's law of heating, what we can say, heat energy produced in a wire is directly proportional to square of current, directly proportional to resistance of wire, and directly proportional to the time for which current is flowing. What are the application of electric heating effect of electric current? To see here, what are the application? First, it can utilize for heating effect in the, you can say, electric iron or toaster or geysers, room heaters. So see here, first point, it utilize in the working electric appliances like room heaters, there you can use, geysers you can use, electric iron you can use toaster. There's a different electric appliances where we are using the heating effect. There what we are using, actually we are using there generally high resistance wire like nichrome, manganese, like that wire if you are using, they becomes very hot and they giving heating energy, and that heating energy we are use in different purpose. फॉर एग्जांपल जैसे मैंने बताया अभी रूम को हीट करने के लिए हैं, वाटर वगैरह जो है क्या करने के लिए, गर्म करने के लिए, ठीक है. सेकंड व्हाट वी आर यूजिंग इलेक्ट्रिक बल्ब वगैरह में भी हम किसका यूज करते हैं, वहाँ पर क्या होता है कि व्हेन दे बिकम्स हॉट दे आर इमिटिंग लाइट एनर्जी, ठीक है, लाइट एनर्जी आर एनर्जी इन द विजिबल रेंज. So second, it utilize in electric bulbs for producing light by using tungsten metal. You can use there for the purpose of when it becomes heat, they emit light energy or light. Third, heating effect is used in electrical fuse. In fuse also we are using heating effect to protect our electric appliances. घर वगैरह में भी आप ध्यान से देखोगे, होम वगैरह सर्किट में हम इलेक्ट्रिक फ्यूज का यूज़ करते हैं. व्हेन देयर इज एक्स्ट्रा करंट और शॉर्ट सर्किट्स, व्हाट हैपन, फ्यूज बिकम्स हॉट एंड इट मेल्ट डाउन एंड अदर अप्लायंसेस हैं बिकम सेफ, ठीक है. तो वहाँ पर भी हम हीटिंग इफेक्ट का यूज़ कर सकते हैं. अच्छा, एक चीज़ ध्यान दीजिए, कॉमर्शियल यूनिट जैसे घर में आप लोग कहते होंगे ना 5 यूनिट बिजली खर्च हुई, 10 यूनिट, 20 यूनिट. तो व्हाट इज यूनिट, एक्चुअल में यूनिट इज कमर्शियल यूनिट ऑफ एनर्जी. व्हाट इज कमर्शियल यूनिट ऑफ एनर्जी? तो कमर्शियल यूनिट ऑफ एनर्जी इज KWH, किलोवाट आवर. कमर्शियल यूनिट इज किलोवाट आवर. 1 kilowatt hour is called 1 unit. You can say 1 unit. 1 unit consumption of energy mean 1 kilowatt hour. If you want to convert this 1 kilowatt hour in the form of joule, so see here 1 kilowatt into 1 hour. 1 kilowatt multiplied by 1 hour. 1 kilowatt mean 1 into 10 raised to 3 watt. 1 hour, if we will convert in the form of second, so 60 into 60 second. So 10 raised to 3, 60 into 60. Here watt second. Watt second is called joule. So 6 into 6, 36. So 3.6. If we will convert in the form of 10 raised to power 6, 36 and 3 plus 2, 6. That means joule, watt second joule. So 1 kilowatt hour, 1 unit electrical energy consumed by a household circuit. So that is 1 unit is 1 kilowatt hour, 3.6 into 10 raised to 6 joule. इसमें टॉपिक है कि इलेक्ट्रिकल पावर. व्हाट इज इलेक्ट्रिकल पावर? तो यू नो पावर वाट, work done per unit time, that is called power. Here electric power of electric appliances is known as electrical energy expended, consumed per unit time, that is called electric power. The electric power is defined as electric power is defined as electrical energy consumed per unit time. Electric energy consumed per unit time. This is known as what? Electrical power. That is also denoted by P. So power is equal to what? Power is equal to electric energy that may be in the form of heat energy, electric energy or heat energy per unit time. And seen here, if current I flows through a resistance R for time t, what is heat energy consumed, electric energy consumed? That is three formula. There I have given VIT or I square RT or V square T upon R. If you are putting here, so power is equal to what? H. In the place of H, if you will write VIT upon T. If you are writing I square RT upon T, if you are writing V square T upon RT, so T cancel. So you will see electric power P is equal to what? VI, or one more formula, I square R, yeah, V square. Very important formula, electric power is equal to VI or I square R or V square upon R. Unit, what is the unit of power, electric power? Unit we know, that is watt, or you can say joule per second. अच्छा, इसकी बड़ी यूनिट अगर हम देखें, बिग यूनिट 1 किलोवाट, 10⁻³ watt. Megawatt, 10⁻⁶ watt. These are the big units. One more unit you know, horsepower. Horsepower, what is horsepower? 746 watt. ये कुछ चीजें मैंने आपको बताई इलेक्ट्रिक पावर.